Okay, we're going to work on evaluating logs that we can actually calculate, kind of figure out by hand here. When I have a log expression that I want to solve, what I like to do is say that it's equal to x. Okay, and then once you have that, I like to take that and change it from log form to exponential form. So if you aren't sure how to do that, can't remember, you can watch the video on that. But I'm going to take this and log base 2, so 2 is the base, and my log is equal to my exponent, so x is my exponent, and it equals 8. So once you get it like that, you can kind of think about it, and usually you can just kind of figure it out. Sometimes you have to do it a little bit by trial and error. But 2 to what power would equal 8? You can try, 2 squared is 4, it's not that. 2 cubed, 2 times 2 times 2 is 8, there it is. So x must be 3. Okay, log base 25 of 5. If I put that equal to x, and I say log base 25, so 25 is my base. My log always equals my exponent, so x is my exponent, and that has to equal 5. What power would I raise 25 to get 5? This is kind of a tricky one. 25, it's not a nice even power. You're thinking probably 25 to the first power is 25. 25 to the second power is really big. So how am I going to get 5? And actually the square root of 25 is 5. And if you have your fractional powers down, you know that taking the square root is the same as raising something to the 1/2 power. So x has to be 1/2. 25 to the 1/2 power means the square root of 25, and the square root of 25 is 5. So your answer is 1/2. Okay, log base 3 of 3 to the 4th. And any problem that's kind of like this, where the base is the same as this base here with an exponent, watch what happens. It's going to follow through for any problems that have the same numbers in those two spots. Okay, let's still put x here. I want to convert this log to exponential form. So I've got my base is 3, so my base is 3. My log always equals my exponent, so x is my exponent, and that's going to equal this 3 to the 4th. You don't really have to do any other math. When you're looking at that, you can see that the only way this could be true is that if x was 4. Okay, log base 5 of 125th. Let's make that equal to x, and let's convert this into exponential form. 5 log base 5, so 5 is the base. Log equals the exponent, so x is the exponent, equals 1/125th. Okay, now this one's kind of strange as well. It has something kind of weird with it. I'm thinking in my head 5 to some power to be 125. 5 times 5 is 25, times 5 again is 125. So to the third power would be 125, but not 1 over 125. So how do I get the reciprocal of that? And the way we do that with exponents is raising to the negative power. So this would be to the negative third. The negative power would make it change from 5 to the third to 1 over 5 to the third. And 5 to the third is 125. So negative 3 is your answer. On this last one, log base 7 of 1, again, we can just kind of go through the same thing. I want to write my base is 7, and my exponent is x. And that has to be equal to 1. And I'm thinking 7 to what power is 1? And then I remember, oh yeah, anything to the 0 power is 1. So I know here x has to be 0. In fact, if I have the log base anything of 1, it's always going to be 0. So once I see I'm taking the log base something of 1, I don't even have to check the base really. I just know it's going to be 0 right off the bat.